A warm greetings to everyone. Now we are going to see about graph data structure. I am D.M.Kalai Selvi, Assistant Professor, CSE Department, RMD Engineering College. First, we have defined a graph data structure. So, graph will come under nonlinear data structure. So, data structure is a way of organizing data. Non-linear means based upon the dynamic addition of data, the location, the allocation of memory will differ. The definition for graph is a finite set of nodes with edges between the nodes. So a graph we can compresses of a set of vertices and edges. So each node will be called as a vertices and the connection between the two vertices are called as edges. So you will be having a finite set of nodes. And we can say edge as a subset of vertices. We take this graph, W V is equal to 0. So totally 5 nodes, 0, 1, 2, 3, 4. So 5 nodes are there. And we can say nodes or vertices and the edge 0 to 1 is a edge. So connection between the node 0 to node 1 is called as edge. So the possible edges for the given graph is 0 and 1, 1 and 2, 0 and 3, 3 and 0, 2 comma 2. So 2 comma 2, if you consider this, this edge is a self edge, self loop. 4 comma 3. So it's an example of a graph. So we can say for node 0, 1 and node 3 will be the adjacent nodes. For node 1, 0 and 2 will be the adjacent nodes. We can say it as a we can say it as a neighboring nodes or adjacent nodes. So the adjacent nodes are considered only when there is a the flow from that node to the next node. So we can say as 0 is adjacent to 1, but 1 is not an adjacent to 0 because we will know the direction of the edge, the flow coming from 0 to 1 and not from 1 to 2. So for node 1, the adjacent edge will be only 2 only. For node 2, the adjacent edge will there be no adjacent edges because we consider for node 2, there is no direction going from node 2 to the next nodes. So that will be no adjacent edge. For node 0, the adjacent edge will be 1 and 3. For node 4, the adjacent edge will be 3. Now we are going to see how to represent a graph. So you have two types of representations, adjacency matrix representation, adjacency list representation. Adjacency matrix is, we can say a general meaning of matrix like a row cross column model. We will see in mathematics. So we have a two-dimensional array. If a single dimensional array, only one row. We are considered two-dimensional array, three-dimensional array, n cross n dimensional array. So this is the way we will represent a matrix. And if your value in that array is 1, if there is an edge between the two nodes. So A of I and J. So I will be one known name, J will be one known name. If there is a edge between I and J, then the value will be 0. Otherwise, the value will, if there is a edge means the value will be 1, otherwise the value will be 0. So if you say for this graph, if you see from the first one will be 0 comma 0. So there is no edge for 0 comma 0. And here it will be 0 comma 1. So 0 comma 1 we having a edge, I'm putting 1. And then 1 and 2. 1 comma 2 there is an edge, I'm giving 1. So here it will be 1, not 4. So here it will be 1. So this is another example. So from 0, the same way, we will be compressing and labeling the nodes with zeros and ones. With the numerical labels. And if there is a age between from Mary, if you consider this node, Mary, node 0, there is no age going from Mary to the next one. So there is no age. So the value for this entire thing will be 0. There is no age coming from Mary. If you see similar to John, there is no you take Helen, all the age are going towards Helen, not from Helen. So for Helen also everything will be 0. So in this way, we will be putting the values. Next, adjacency list. So adjacency list like a linked list. So for each node in the graph, we will be combining the list of nodes connected adjacent to that one. So if you take Mary, node 0, there is no link going from, that is this direction. From Mary, there is no connection is going. So the list is empty here. If you consider 1, that is Helen, for this also no link going from Helen. So it is empty. If you go for L2, that is John. From John, we are going for 0, that is Mary, 0, 1, 4, and 5. And similarly for 3, 1, 0, 4, and 5. So there is no need to write in order. We will write based upon our description purpose. For node 4, only 2 nodes are going towards from Tom towards the other directions. So Mary and Helen, 0 and 1. Similarly for node 5. Thank you.